What's up, kids? I am Teacher Rommel. I will be your science teacher for today. Welcome to our online video tutorial. Before we start, make sure that you have the following materials with you: your book, notebook, pen, and a highlighter. Let us have a recap of what we've discussed last time about spin. First, we've said that spin is the rate at which the object changes position. Second, we learned that velocity describes both the speed and the direction of the object. Third, we've also learned acceleration, which we define as any change in the speed or direction of the object's motion. Moreover, we've talked about the 3 steps to calculate the average speed of the object. First, we've said that we find the distance an object moves. Second, we have to find the time it takes the object to move that distance. And finally, we have to divide the distance an object moves by the time it takes to that distance. We've also learned about the importance of graph. We've said graph is important because it helps us see the data easily. Maybe most of you have already seen a lightning. Lightning is one of the sources of huge amount of electricity if we could learn and invent a device that can catch it and store it. Today, I'll be giving you some interesting trivia about lightning. Did you know that a flash of lightning can heat air around it to about 30,000 degrees Celsius? It is 5 times hotter than the surface of the sun. Further, one flash of lightning has enough electricity to light an incandescent lamp for more than 3 months. In addition, lightning strikes the ground in the United States more than 20 million times. And it is so frequent that maybe any one of us can never thought of. Lightning is related to electricity, which is our topic for this session. Our learning objectives for today are: first, investigate how electric charges flow in a circuit. Second, classify conductors and insulators. Third, differentiate series and parallel circuit. To be able to understand electricity, we have to understand first the basic concept of electric charges. Let us start by discussing the atom. The atom is the tiny building block of everything. It is composed of 3 different particles: the electron, proton, and the neutron. Electron is the negatively charged particle. The proton is the positively charged particle, and the neutron has no charge. Inside the atom, the electrons are freely moving on their orbit around the center part, which we call the nucleus. This is the area where the proton and the neutron are located. Let us now study static electricity. The word static means static or not moving. But when we talk about static electricity, we talk about here electric charges that are moving. We might ask ourselves, how does the static electricity happen? Well, it happens that positive and negative charges are not balanced. You can actually relate it to a force. When there is an unbalanced force, there is a movement created. might have experienced a jolt of electricity that startles you when you walk on the carpet and touch a doorknob. Let us now explain how does the carpet and the doorknob related to static electricity. When you drag your feet across a carpet, you are creating many surface contacts between your feet and the carpet, allowing electrons to transfer to you, thereby building up a static charge on your skin. Charge imbalance is created between you as a conductor and the carpet as an insulator. When you touch a doorknob, which is metal, all the charge wants to leave your body and go to the doorknob in order to restore the balance of the charges. Therefore, you get a shock as the electrons hit you. Charged particles can move between objects that are close to each other. Moving charges generate electrical energy, which can change into sound energy, heat energy, or light energy. Let us now define electric current. Electric current is an electric charge in motion. Look at this illustration. The moving particles are actually the negatively charged particles. These are the electrons. Therefore, electric current can also be defined as the movement of electrons. It flows quickly and invisibly from one place to another. I have here different types of materials. Can you help me which of these materials allow the pass-through of electricity? Brilliant idea! Spoon and fork and metal scissors are actually materials that allow the pass-through of electricity. These materials are called conductors. Conductors are materials through which an electric charge can move easily. Examples of this are metals such as copper, gold, and silver. Lead or graphite on the pencil is also an example of a conductor. On the other hand, insulators are materials through which an electric charge moves with difficulty. Eraser on your pencil and chalk are examples of insulators. And let's talk about the electrician. Electrician is a person whose work is related to electricity. Look at these pictures. An electrician here is wearing rubber shoes and rubber gloves, which are insulators. This prevents him from the damage that might cause with the flow of electricity. Look at the picture of this device plugged in a socket. If you remove one of these and study it well, the plug and the wires inside the electrical cord are called conductors. The plastic insulator makes the cord safe to handle. One of the most important questions that we need to answer for this session is, how does electric charges flow? Before we answer this, we have first to define the word circuit. Circuit is a complete loop where electricity can flow. For a current to flow, electric charges must complete a loop for a circuit. This is an example of a simple circuit. This is a loop in which charges can flow through. Circuit is consist of different parts. First, it has energy source. provides energy to move electric charges. In this case, we have a cell. Two or more cells are called battery. Next, we also have here a wire. It is a material where electric charges flow. We also have here switch. It opens and closes the circuit. And lastly, we have resistor. Resistor transforms energy to other forms of energy. In this case, we have a bulb. Let us take a look at the picture of two circuits here. The open and the closed circuit. You will notice that in a closed circuit, the bulb lights up, whereas in an open circuit, the bulb does not light up. This is because the electricity in closed circuit can flow through all around the loop. However, in an open circuit, the electricity cannot flow through since there is a break. Notice, the switch in open circuit is off, while the switch on a closed circuit is on. Remember, closed circuit has no break, but open circuit has. Circuit is of two types. The first type is a series circuit. In this circuit, electric charge can flow only in one circular path. The second type of circuit is called parallel circuit. It has two or more paths through which electric charge may flow. This is an illustration of a parallel circuit. So basically, the only difference in this illustration is the number of their paths. Let's count the path of a series circuit. It's 1. For a parallel circuit, we have 1, 2. Look at these illustrations. What do you think will happen if one bulb is busted in each circuit? Let's find out. In a series circuit, if one bulb is busted, the other bulb will not light up. Remember, there is only one path for the electricity to flow through. Thus, when one bulb is busted, the electricity cannot flow through the other components since there is already a break. However, in a parallel circuit, if one bulb is busted, the other bulb will still light up. This is because it is composed of two or more paths for electricity to travel. If one path is broken due to the busted bulb, there is another way for electricity to flow. Let us study this picture and answer this question. Which do you think among the competitors here is finding it easier to build a circuit? Very good. The one who built this diagram. This is because he only makes use of symbols. We know that we can represent circuit through symbols. The graphical representation of an electric circuit is called circuit diagram. But before we do this, we have to know first some basic symbols used in an electric circuit. Here are the 4. First, we have the bulb. Second, the energy source. We also have the switch and the wire. This illustration shows a circuit diagram of a parallel circuit with two bulbs. This one represents a circuit diagram of a series circuit with 2 bulbs. Before we end this session, let us first have a wrap-up of what we discussed today. We have said that electric current is an electric charge in motion. It moves quickly and invisibly from one place to another. Second, we discussed that conductors are materials through which an electric charge can move easily. And third, we talked about insulators. We've said these are materials which an electric charge moves with difficulty. In addition, we also learned about circuit, and we defined it as a complete loop where electricity can flow. Also, we've discussed the 2 types of circuits. The first one is series circuit. It has only one path for electricity to flow. That is why, when one bulb is busted, the other bulb will not light up. The second type of circuit is a parallel circuit. It has 2 or more paths for electricity to travel through. This is the reason why even one of the bulbs is busted, the other bulb can still light up. This is because there is another path for electricity to travel through. That's all for this lesson. For additional information and homeworks, don't forget to log into your Person Realize account. See you next time. Bye!